Hello, I'm Javier Jimenez, and I'm here today to discuss a little bit about PAM for flood control. I'm application engineer in Flowserve, Coslada, Spain. So let's start. Okay, so when we talk about flood control, we really need to talk about the Netherlands. It's a country where the most of its area is below sea water level. And they've been facing this problem and working on this problem for many years. But I want to ask, is that a problem that only the Netherlands has been facing? For sure, the answer is no. So let me provide a little bit of background. As you all know, the Netherlands is a quite dense country in Europe, and a small country. But the point that we wanted to highlight today is that 26% of the Netherlands is below sea level. And also we've got a 29% of the area which is also sensitive to river flood. So this leads to a 50% of the area at risk of flooding. So back in the early 19th, the Dutch authorities demanded a very reliable pump, and it was developed in 1929. The first pumping station, the station of Lely, was the first one with a concrete volute pump. Currently, there's many pumps installed worldwide. So the problem is here, the flood control. We've seen that the Netherlands has been working on it from a long time ago, but what about other countries? Have they done their homework? And I would like to discuss a second point. There's a new player in the game. So the problem is clear, risk of flooding, but if we add the climate change, which is increasing the sea level, and extreme conditions are becoming more and more frequent, this leads us to a bigger problem. So there's new areas at risk, and it's becoming more and more frequent. So we already gone through the problem. The question is there any solution up there? The answer obviously is yes. So the solution would be a pumping station, and I would like to divide a little bit. There's two big families: steel pumps and concrete volute pumps. And inside steel pumps and inside concrete volute pump, we've got different hydraulic to be able to cover mixed flow and axial flow needs. Okay, so we've seen that there are solutions out there in the market, but if I think about a flow control pumping station, what are the key features that I would like that I think that my pump should have? So the first one is pump operation readiness. I want to be able to operate the pump when I need it. I want reliability, so I want a really robust pump that is able to operate if there's a flooding ongoing. I would like a low maintenance pump, definitely. It's a pump that is gonna be mainly stopped throughout the year, so um, we need to avoid corrosion as much as possible. We would like to be fish friendly, so these pumps are handling river water or sea water, and we need to take care of the life inside those waters. And I would like the best efficiency possible for the application, and I would like to decrease my civil cost as much as possible. So just to reinforce my previous message, so I want to build a pumping station. So I would have certain performance conditions. So we've got flow and TDH. I would like the, the higher efficiency achievable for the specific application. I would like to decrease as much as possible civil work at site. So how can I do that? First, by minimizing the depth of the pit, which is something that we can achieve selecting CVPs. Minimizing the footprint by reducing the number of pumps, so selecting bigger pumps. And finally, using concrete prefabs, which allow to really deliver a very high quality concrete volute, which is casted under control condition, and then this save a lot of time and cost for the civil work. And definitely we would like aquatic-like flotation, and Flowserve have fish-friendly hydraulic to go through this problem. As we've mentioned before, Flowserve do have a family of steel pump, and we can cover the whole operating range with different hydraulic, and we also have concrete volute pump with the mixed flow and axial flow pump. So, and we are gonna focus this presentation into concrete volute pumps. So basically, what we can see in this chart is the area of flow and TDH that we can cover with steel pumps and with concrete volute pumps, and also that as we have discussed with CVPs, we can get higher TDH and slightly lower flows. Whether with CVPS, we can get higher flows with slower TDH, but mainly that many areas of the chart you can see we can cover with steel pump or with concrete volute pumps. So, as I mentioned before, we will focus this presentation most on concrete volute pump, which are not that common out there in the market. So first, I want to introduce you the CVP mixed flow concrete volute pump. It's a mixed flow hydraulic pull-out design, so we can extract the rotor together with the impeller for maintenance purpose. We can achieve really high efficiency with this kind of pump, and I mean it has a really advanced varying design, and as you can see here, it is driven by a motor plus a gearbox. Also, motor configuration only without gearbox can be also studied. Okay, so we've got here a CVP. We've got the pull-out element, which is the one, yeah, this external part is in contact with the water. We've got the impeller, and then the water will go through the suction box. Okay, we provide the shattering for the suction board in order to shape this element. Then we'll go through the suction bell made up of concrete here. Then we'll go through the volute, okay, number 4, and then finally through the metallic part, which is the transition piece, which is the connection, the interface between the pump, the concrete part, and the customer pipe. So a key feature of this pump are the prefabricated elements. I mean, as we have discussed before, we've got here the suction box, the suction bell, and the volute of the pump. Those parts are made up of concrete. So with the main advantage of being corrosion-free part of the other pump. But yeah, a key feature is that it's not only that they are made up of concrete, but they are prefab element. And we're gonna see in the next slide what is the main benefit of that. So we can achieve longer pump life due to the fact that these are corrosion free. We definitely reduce the construction time much faster to deliver this aside, assemble, and that's it. And linked to that, we can reduce also the cost. Another really important point is that these parts are manufactured in a control area, so performance risk, because remember these are hydraulic part of the pump. So in order to warranty the quality and the surface finishing quality is I mean it's a main advantage that it can be manufactured on a control area. So we've seen the CVPs already, axial, mixed flow pumps, and now we are gonna jump to CVPS, axial flow concrete pumps. So, I mean, basically it's the same design, so pull-out design, slight different here on the static spiral. We've got here the impeller, and and the other point are mainly the same. So we've got here also the suction box, the volute, the the suction bell, the concrete volute, also the technicians have access to sealing and bearing, so pretty much the same. The key point here is that different hydraulic to be able to provide higher flows and slightly slower heads. We've got two design of fish-friendly impeller, one for mixed flow pump, so slightly higher TDH single blade design, and a dual blade impeller. So here in the picture it cannot be appreciated, but this impeller has 4.5 meter of diameter, so it's a really huge impeller, fish-friendly impeller. So one of the questions that you may have is how can we test this pump since the volute is made up of concrete? So the solution to that is that we do a model pump, so reduced size, in order to test the hydraulic. We've got a dedicated test bench in Flowserve. Then we also have the capability to test the suction box. There's two ways, either with CFD and or some model test. And finally, we perform a mechanical performance test at site in order to see that the pump can work properly. In this slide, you can see in the left-hand side our test bench to perform the SAM model test of the pumping station, and on the right-hand side you can see able site test. I'm going to present now 3 cases where we've got CVPs already installed or just about to be installed. The first one, I want to mention the Netherlands as fluid dike project, where Flowserve is just about to deliver 6 CVPS pumps, which will move a total flow of 846,000 cubic meters per hour. This is a huge dike, which is separating the lake and the sea, and with a with a system of gates, it will get advantage of the tide in order to pump water naturally from the lake to the sea. But what happened with the climate change? It is expected that the low tide water level will increase, and then this system at a certain point will not work properly. That's why when they think about this, and they have already take this into account, installing 6 of these pump. So we can see in these two pictures that Dallas has been a city that has been dealing with flood along its history. So, but they are already working on the problem. So they already have 3 pumping stations in the river corridor. So Pavajo, Baker, and Abel. The pump has been delivered by Flowserve, and now they are working on 3 new pumping stations, which are Hampton, Charlie, and Portland. Finally, we've got Bangkok, which already, I mean, all around Bangkok, we already have 5 pumping stations, which are meant also to control the flood in the city. Just to sum up, I just wanted to recap the main ideas of the presentation. So first one, let's say we've got a problem, flood control. So it is affecting new areas, and it becoming more and more frequent, those intense rains and floods. So I just want you to keep in mind that Flowserve do have a solution for that. We've got a wide variety of pump, but specifically we've got the concrete volute pump. And I just want, when you think about concrete volute pump, I mean the first thing that need to come to your mind is that it's a reliable pump, low maintenance pump. And also the final idea is that, I mean, Flowserve do have a solution, environmental friendly, with the fish safe hydraulic. So I just wanted to mention that there's some videos of this pump available on YouTube. So I encourage you to have a look at this. And for sure, if you have any question, please contact Flowserve, and we will be glad to help you. Thanks a lot for your time.